Good morning, students. Today I have discussed about electricity, and first of all we have to discuss about what is meant by electric current. Definition of electric current. So the definition of electric current that related with the electric charge. So first of all we have to discuss about the electric charge. Electric charge is the fundamental particles of any atom which having positive, negative as well as neutral characteristics. It means positive, negative and neutral characteristics means the fundamental particles like electron, proton and neutrons are there. Electrons always present in the outermost shell of the orbit, as well as when we have to discuss about the proton and neutron, they are established in the nucleus and it not emit from the nucleus. If it emit from the nucleus, then the establishment of nucleus, or we can say that the existence of nucleus is to be vanished. So now we have to discuss about the electric current. So what is meant by electric current? Electric current may be defined as the amount of charge which is flowing through the metallic conductor of unit cross-sectional area in unit time. It means what? How many amounts of charge which is flowing through this metallic conductor. Suppose that this is our marker and we consider, or we have to suppose that this is our conductor. So when we have to discuss about this conductor, so how many electrons or how many charges are flow through this cross-sectional area in unit time. So that rate of charge is known as electric current. So that we have to write here the amount of charges which are flowing through the metallic conductor of cross-sectional area in unit time is known as what? Electric current. That is I is equal to Q by T. Where what is meant by Q? Q is the charge which is equivalent to N dot E, where is N is number of electrons. How many electrons are emitted from the cross-sectional area? That amount is known as here N. And how the one electron charge, we already know that the one electron charge, how much charge in one electron? We already know that there is a minus 1.60219 into 10 raised to minus 19 coulomb charge are there. So when we have to multiply with the number of electrons, then we get a amount of charge Q, and this amount of charge is flowing through metallic conductor in unit second. It means what? It depends on in 1 second how many electrons are passes through the cross-sectional area of the metallic conductor. That amount of charge is known as, that rate of amount of charge is known as electric current. And the SI unit of electric current is what? The SI unit of electric current is ampere. It will be given by the it was given by the ampere. The name of the scientist is ampere. That's why they give the credit of the SI unit of the electric current is ampere. Now we have to discuss about the what is the direction of the electric current related with the flow of electrons, because we have already know that according to the Newton's third law, every action has equal and opposite reaction. So that concept we have to first of all take in as a mind. Then if the direction of electron is in forward direction, suppose this is our electric circuit, suppose that this is our electric circuit, there is a battery, and if we have to draw a bulb like structure, and this is a positive, this is negative, so there is so many electrons are there. The number of electrons are very crowded in here. So if the electrons are drifted from this position to negative terminal to the battery, then what will happen? Then there is a positive charge remains. Once the electrons are shifted from this end to this end, then what will happen? There is a positive charge remains. So if suppose that there is so many electrons, so one electron is pushed the another neighboring electrons, then what will happen? Then the Newton, according to the Newton's third law, they comes in the backward direction. But what will give? They transfer to the forward direction. What they will give? They will give a energy. So this energy is known as electric current. So the direction of electric current is forward direction, but at same time the direction of the electron is the backward direction. So we have always keep in mind the direction of electric current is always opposite to the direction of the flow of electrons. That's all. Okay, thank you so much.